in an algebra class, we typically spend a ton of time simplifying expressions. For this class, simplifying expressions is not going to be one of our main tasks, but it is something that we should be familiar with. And there are some basic moves that we're allowed to use to simplify expressions. And I'm going to just go through these moves. And again, we're going to think about them in terms of how they make sense if X is the number of cookies in a box. And so each number we have represents some number of cookies. So the first move we have is to just kind of do arithmetic to combine numbers. So let's say we have 3 times 2x plus 3 plus 5. So 3 times 2x is going to come first because that's multiplication. So we'll think we have 2x representing 2 boxes of cookies. And we want to make 3 copies of that. So we'll have a second 2x and a third 2x. And so that gives us 1, 2, 3, 4, 5, 6 boxes of cookies. So that gives us 6x. And notice that functionally what we've done is multiplied 3 times 2 is 6. Okay, so then let's look at the addition. We're adding in 3 extra cookies. And we're adding in 5 extra cookies. Well, we can combine these and say we have 1, 2, 3, 4, 5, 6, 7, 8 extra cookies. And functionally what we've done here is just 3 plus 5 equals 8. But we can't combine the 6 boxes of cookies and the 8 extra cookies because we don't know how many cookies there are in each box. So we don't know if the 8 extra cookies give us like 4 extra boxes or if they're not even enough to make up 1 extra box. We just need to leave it as 6x plus 8. We think of this as 2 boxes of cookies 3 times, then 3 extra, then 5 extra. And that ended up giving us 6 total boxes, 8 total extra cookies. The second tool we have at our disposal is what's called the associative property. The associative property applies if our only operation is addition or if our only operation is multiplication. If we're mixing addition and multiplication, we have to be more careful. But here in the expression x plus 4 plus 1, these parentheses are saying you have to add the x and the 4 together first and then add 1 to it. Right, so we've got a box of cookies plus 4 extra cookies. And then 1 cookie after that. But here's the thing. We can combine these extra cookies with this extra cookie without changing how many cookies we have. So we can say we've got this one box of cookies. And then we've got these 4 extras and this 1 extra. In other words, this x plus 4 plus 1, those parentheses don't actually mean anything. They don't actually change the value of the expression. And so we can rewrite this as x plus 4 plus 1 without the parentheses. And then we can combine the 4 plus 1 using the move we just talked about and say that that's x plus 5. We can think of this as a box of cookies, 4 extra, then another 1 extra. But that's just the same as having 5 extra cookies. And the biggest reason I mention the associative property here, which is pretty intuitive, is to help us distinguish it from this next property, which some people find a little bit less intuitive. This next property is called the distributive property. The usual rule is, if we have addition and multiplication, we have to do the multiplication first. If we want to break the usual rules, we use parentheses around whatever operation we want to do first. So if we have 3 times x plus 1, those parentheses are saying, even though the usual rule is to do multiplication first, in this case we want to do the addition first. So we'll take x plus 1 and then do that 3 times. So x plus 1, right, that's a box of cookies plus an extra. So that'll look like this. And then we're going to make 3 copies of that whole thing. So a copy of the box of cookies and the extra, and another copy of the box of cookies and the extra. And so what we end up with is 3 boxes of cookies and 3 copies of the 1 extra, which is 3x plus 3. We can think of this as a box of cookies plus 1 extra, then make 3 copies of that. The reason this is called the distributive property is we think of this move as distributing the 3. So everybody gets a 3. 3 times x plus 3 times 1. Right. Do we need to write down this step where we have the 3 times 1? As a rule of thumb, you should write down those middle steps if you're going to use your calculator for the arithmetic. We can multiply 3 times 1 in our head, so we can just write down the answer. We can just write down 3x plus 3. If the numbers were like 2/5 and 7/8, I might want to use a calculator to do that multiplication, in which case I would write down the multiplication in that step. Okay, the last move we're going to see is what's called combining like terms. And combining like terms means we're adding and subtracting, and we have both numbers and variables. Some of our terms have exactly the same variables in them, and we would like to combine those in order to have fewer variable terms. Combining like terms was what we did in our very first pair of equivalent expressions to go from 2x plus 3x to 5x. So if we have 3x plus 5 plus 2x, right, we think we have 3 boxes of cookies. Right, so here's our 3x. And then we have 5 extra cookies. And then we have 2 more boxes. And so what we want to do is combine those 2 x terms. In other words, combine our numbers of boxes of cookies. Right, so we have 3 boxes of cookies plus 2 boxes of cookies. That'll give us 3 plus 2 boxes of cookies. And then 5 extra cookies. So we can rewrite this expression as 5x plus 5. And we're thinking 3 boxes of cookies, and then 5 extra cookies, then 2 more boxes. And when we combine those, we have 5 boxes and 5 extras. This last one, we also have subtraction. So let's see how that goes. So we have our 5 boxes of cookies to start with, right? That's our first term, 5x. And then minus 2. So I'm going to take away 2 cookies from one of my boxes, and I'm just going to represent that with some dots inside. Then I've got minus 3x. So I'm going to take away 3 boxes. And finally, plus 4. Well, I'm going to replace those 2 missing cookies. And then I've got 2 extra cookies. So I'm hoping that I'm going to get 2x for the 2 boxes I have left, plus 2 for my 2 extra cookies. How could I get that? Well, I can think of this as I have a 5x minus a 3x plus a 4 minus a 2. And now I can group these two. And I can group these two. Notice that when I rearranged those orders, everywhere I had a minus sign, I kept the minus with the term it was associated with. Right, so I kept the minus here with this minus 2. And I kept the minus here with this minus 3. And so what we're thinking is this whole narrative. And then we can change the order of when we put things in and when we take them away, as long as we're always taking away 3x, right? As long as the amount that we're taking away stays the same. So we start with 5 boxes. We take away 2 cookies. Then we take away 3 whole boxes. And then finally, we add in 4 cookies. And we look at where we end up. In addition to simplifying, the other thing we might do with an expression is to evaluate it. To evaluate an expression means just to work out the value, work out what number it represents. In order to evaluate an expression, we need to keep in mind the order of operations. Now, you've probably seen this acronym, PEMDAS. And that is an acronym for the order of operations. It helps us remember parentheses, then exponents, then multiplication and division, then addition and subtraction. These two and these two are actually the same thing. We'll talk about that in a second. Keep in mind that parentheses are actually not the only grouping symbol available to us. For example, the fraction bar also acts as a grouping symbol. And this makes us think there are a lot more steps than there really are. Right? There are really only 3 rules to the order of operations. Exponents have to happen before multiplication. Multiplication has to happen before addition. And if you want to do something else, if you want to violate that order, then you have to use grouping symbols. So you have to use parentheses or fraction bars or something else that groups our symbols. So notice in this order, we didn't mention division, and we didn't mention subtraction. And that's because those aren't really real operations. Division, what we call division, is really just multiplication in a funny hat. When we want to divide by some number, we're actually multiplying by its reciprocal. So for example, if we're taking 6 divided by 3, that's actually 6 times 1/3. Similarly, what we call subtraction is just addition in a funny hat. When we're taking 5 minus 2, that's really 5 plus -2. And here I'm writing the -2 in parentheses again, so that it's clear that we're talking about adding the number -2. When we're doing algebra, we almost never write division using the divided by symbol. We almost always write division using the fraction bar. And that's because it makes the order of operations easier to read. So let's practice running through the order of operations to evaluate an expression. So anytime we have a piece of this expression that contains both multiplication and an exponent, the exponent has to happen before the multiplication. Anytime we have both multiplication and addition, the multiplication has to happen before the addition. So a good way to go through the order of operations is to first find all the additions and subtractions, because that chunks our expression up into pieces that we'll evaluate separately before we do the addition and subtraction at the end. In our first piece here, we have an exponent. So the first thing we're going to evaluate here is -2 to the second power, which means -2 times another -2, which a negative times a negative is positive, so that'll work out to +4. And so in our first piece here, we'll have 3 times 4. Now in our second piece, there aren't any exponents. So we just have 5 times -2. A positive times a negative is going to be negative. So that second piece is -10. And then our third piece is just a 7. Now again, we have 3 pieces, a 3 times 4, a -10, and a 7. The only one of those that still has any arithmetic to do is 3 times 4 is 12. And now we have 12 plus -10 minus 7. Plus a negative is the same as subtraction. So we'll say this is 12 minus 10 minus 7. And now we're going to proceed from left to right, because all that's left is addition, disguised as subtraction in this case. So we've got 12 minus 10 is 2. And finally, we have 2 minus 7. Smaller minus bigger, go the other way around, but then make it negative. So 2 minus 7 is 5, make it negative. We get -5. That's how we would do that by hand. Now, if you're not super comfortable with the arithmetic of negative numbers, or you're not super comfortable with that long, tedious process, good news, we can have the calculator do this for us. Our calculator knows the order of operations, so we can just take this whole expression exactly the way we see it. To enter an exponent, we have an exponent key directly above the division key. We type in the exponent that way. When we're done typing the exponent, we hit the right arrow key to get out of the exponent. And then we can continue with the rest of the expression. So we can enter the whole thing just exactly the way that we see it, hit enter, and that gives us the same answer. In order to evaluate an arithmetic expression, all we need to do is follow the order of operations. However, if we have a variable expression, we also need to know what numbers the variables represent. So, for example, if we want to evaluate the expression 3x minus 7y plus 4, well, we need to know what x represents and what y represents. In this case, we know because we're told, right? We're told directly that x represents the number 5 and y represents the number 2. So in this case, we can do what's called plugging those in. Okay, so sometimes when we're working with more than one variable, it can be challenging to keep track of what we're doing. So I'm going to show a way of slowing this down and doing all of the gory details. I'm going to copy my expression, but everywhere I see a variable, I'm going to put an empty set of parentheses with some space between them. And now I'm going to go through and say, what variable was this for each of these parentheses? This was an x. And this was a y. Finally, I'm going to look and see, what did my x represent? X represented the number 5. So I'm going to put a 5 in every blank labeled with an x. What did my y represent? Y represented a 2. So I'm going to put a 2 in every blank labeled with a y. So my expression now is 3 times 5 minus 7 times 2 plus 4. Going through the order of operations, we'll have 3 times 5 is 15. 7 times 2 is 14. And then there's nothing to do for the plus 4. And then finally, we'll go through from left to right. 15 minus 14 is 1. 1 plus 4 is 5. Of course, once we've got our variables plugged in, we can go directly to the calculator and say we have 3 times 5 minus 7 times 2 plus 4. And that will give us the same result of 5.